Okay, for today's lesson, we are looking at repeated percentage change. So we know what happens when we add 10% to something. So for example, £500, add 10%, we're adding on 50, and we get 550. But what happens with repeated percentage change? Do we add on £50 again if we add 10%? Or do we add on £55 of our new value? That's what we're looking at. So we're looking at compound interest. And that is the interest earned each year is added to the money in the account and earns interest the next year. And most banks are like this. So here's an example. We're going to do it the manual way first. So we start with £500 and we add 10%. So I know in 1 year we're going to add £50, so 550, because I've added plus £50. In year 2, well, 10% of 550 is £55, so we're going to plus 55 here. And that gives us £605. So now here we're going to add 10%, so 605 times 1.1, and we're going to get a value of 665.50. Because what I've done this year, I've added plus 60.50 £60.50. So on my next year, we're going to do 665.50 times 1.1. So after 4 years, we are going to have a total of £732 and 0.55 pence. Because last year, what we've done here, we did 665.50 times 1.1 and 10%, and there we are. That gives us our value, and that 10% that last year would have been, we added on, so we plussed on £66 and 35 pence. That's what we do. Now, is there any easier way to do this? That's what we'll be looking at today. Firstly, we'll do this one more time. So, two competing banks of very similar interest. You can see one of them is 1.2% and the other one is 1.3%. Very similar. What is the difference in the balance? So I'm going to start with a bank A. So firstly, year 1, 5,000. We're going to add on 1.2%. So we're going to do times it by 1.012. If you don't know how I've done that, you may want to look back at my other video, but essentially I just found 1.2% as a fraction. So therefore on my calculator, my mental math isn't that good. So there we are, end of year 1, we're going to have £5,060. So now we do year 2. We take that new value, 5,060, times it by 1.012. And that's going to be, right to the nearest penny, here we are, 5,120.72. And that goes here. Year 3, we take that value at the end of the year and we times it by, again, our interest. Okay, now this is on the calculator. I've got a value of 5,182.16864. So for the sake of the calculation, we're going to write to the nearest penny 17. But I'm going to keep the original value in. So the value I got was 5,182.16864. So I'm keeping that on my calculator, but I'm just going to write to the nearest penny here. So the last year, what times it again by 1.012. So year 4, 5,182.16864 times 1.012. I do that just for accuracy. That's what's really important, because if you sort of round down or up a penny, in the long term, it's going to make a huge difference. And this one here on my calculator, 354,664. But up here, to the nearest penny, 5,244.35. Can you do that for Bank B now? And can you tell me what is the difference of them after 4 years? Okay, I'm going to pause it here now. And in 3, 2, 1, you're looking for a difference of £20 and 75 pence, but we'll round that up actually 20.76. That's the answer you should be looking for. Okay, let's move on. Okay, here's a Ross example. So very quickly, David invests £3,000 at compound interest at 2.4% per year. How much money will we have after 4 years? So we start £3,000, year one. So it's going to be 3,000 times 1.024, and that gives us a value of 3,072. So we take that. So I'm going to do this in the nearest penny, but for the sake of my calculation, you know what, I want to write it all out just for the sake of ease. But obviously we can't, we have to round it to do decimal places when it's money. Again, times it by 1.024. So we're going to get 3,221.225472. So after 4 years, I wanted to say answer because it's getting quite long now. That's what I'm looking for. Times it by 1.024. So our final value, I'm going to round this now to 2 decimal places, 3,298.53. Okay, now, what we're trying to spot here, we times it by 1.024, you can see there's 4 times. So on your calculator with me now, I want you to do our starting amount, 3,000 times 1.024 to the power of 4. Tell me what you get. So I'm going to do it now. The power of 4. Interesting, we get the exact same value, and that's how we can calculate quickly compound interest. So that's what we're looking for. Right, let me show you the formula. So that's how much David had that, by the way, after 4 years at 2.4% interest, 3,298.53. Right, so here's a key point. Can you write this down? You can calculate the amount after n years of compound interest using this formula. Initial amount times 100 plus the interest rate over 100 to the power of n. Let me show you. So you got £5,000 at 2.4% interest for 5 years. So what's our initial amount? So firstly, our initial amount is 5,000. Multiply it by 100 plus our interest rate. What's our interest rate? 2.4 over 100 to the power of n years. Well, n is 5. There we are. So that's going to equal 5,000 times 1.024 to the power of 5 on your calculator. 1.024 to the power of 5. So the interest after 5 years is going to be 5,629, and to 2 decimal places, that's going to be 50 pence. There we are. And that's how we do it. As simple as that. Okay, 2 questions here. Please have a go at them. And you got your key point below. And then what I'm going to do is, let me just show you the answer really quickly. So what does it say? Pause now. Okay, 3, 2, 1. Let me show you really quickly. 1,000 at 7% a year for 5 years, and that's going to equal 1,000 times 1.07 to the power of 5. Oh, I'm done to the power of 6 by accident. 1,402.55. And the second one, I'm just going to give the answer now. 4% for 5 years. 1,216.65. There you are. Okay. How go these? 5 practice questions. Now I've been quite cool here. You'll notice a little difference in question 4. Just see if you can work out yourself. Just see if you can use a bit of logic and see if you can go. Deprecate. This is going the other way. So see what happens. Okay. Pause it here. Have a go, and then right, give you your answers. Right. Oh, come on. Right, there you are. Here's the first 3. Question 4. Let's just look at it. It deprecates by 3.5% a year. So this could be the same thing. 1,000 times 100 minus 3.5 over 100 to the power of 7. So that's going to be 1,000 times 0.965 to the power of 7, and that's going to give us an answer of 1,000 times 0.965 to the power of 7 is 779.28 to the two decimal places. Obviously it's money. And the last one, 1,000 times 1. So we got 3%, 3.5% for 4 years, 1.035 to the power of 4, and that's going to equal 1,147.52. Great. Hope this video helps. My class, obviously, you have some questions now on Dr. Frost Maths, but for anyone else watching on YouTube, hope it helped, and I'll see you next time.